Okay, now we want to talk about Pluto, the dwarf planet. And if I had been giving this lecture a few years ago, I really wouldn't have said much about Pluto because we didn't know anything about Pluto. But within the past few years, a probe actually arrived at the planet Pluto. And it has given us a wealth of information about what the surface of Pluto looks like, what the surface is composed of. We can then speculate as to the internal structure of what Pluto is like. So first, general features of Pluto. It is a dwarf planet. So what does that mean? It means that it is so small that it doesn't have much gravity, and that gravity cannot clear its orbit around the sun of debris. So a official planet like Earth and Mercury and Venus are large enough, they have enough gravity that they can sweep out materials that get collected in the orbit as they go around the sun. Pluto can't do this, so it's demoted from being a full-fledged planet to a dwarf planet, and let's all shed a tear for poor Pluto. It's basically just debris that's left over from the formation of the solar system. Okay, next, the orbit. It takes roughly 200 years for Pluto to make one complete orbit around the sun. So imagine that the last time that Pluto is where it is today would have been 200 years ago. Another interesting thing about the orbit of Pluto is sometimes it's inside the orbit of Neptune. So if you were to draw a picture of the sun, and then let's say that this represents the orbit of Neptune, well, Pluto has an orbit that is very elliptical. See, this one is more circular, but a more elliptical orbit for Pluto might be something like this, to where most of the time Pluto is going to be outside the orbit of Neptune. But occasionally it's inside the orbit of Neptune for short periods of time. Okay, then some other interesting features. So what is the internal structure of Pluto? So we think at its core it has rock. So it has a rocky core to it. Then it's going to be surrounded by a mantle-like structure that is going to be composed of water. So the upper part of the mantle, so again, let's draw, this is the core of Pluto, which is going to consist of rocks. Okay, then you've got the mantle, this part here, and so the upper part is going to be frozen water, and then underneath it is going to be liquid water in there. Then on top of this is going to be a crust, and that crust is again going to be composed of ice, and there's going to be some water ice in there, but then there's also going to be some methane ice, there's going to be some nitrogen ice, so there's going to be different kinds of materials that are going to be ices because they're so cold, and then that's going to form a crust on the surface of Pluto. Okay, then surface features. It has a very young surface. Now that really bothered astronomers when they looked at this, because they were expecting it to be heavily cratered just like the moon. So the moon has, our moon has lots of craters on it because it's been heavily bombarded. We expected Pluto also to be heavily bombarded, which it has been, but there's no sign of the bombardment. There's very few craters on the surface. So that means something must be removing the craters. And what could that be? Okay, then another thing that they noticed is it has volcanoes. But they're not the volcanoes that we have on Earth. So on Earth, the volcanoes spew out liquid magma, and then that hardens and becomes igneous rocks. On Pluto, it's going to have ice volcanoes. So volcanoes that are going to be spewing forth materials that are going to freeze and turn into ice on the surface of the planet. And so this process of ice volcanoes produces materials that cover up the surface, and it gets rid of all of those craters that are on there. Okay, so Pluto has a form of plate tectonics, but it's not the kind of plate tectonics that the Earth has. So Earth has plate tectonics because of the internal heat of the Earth from the leftover heat from the formation of the planet, and then also from radioactivity. And so that heat is what causes the rocks to move around and the lithosphere to cause plate tectonics. Well, there is a different heat source inside of Pluto. And so what they think it is it has to do with the ice changing from a liquid to a solid. So that if you have, now this is kind of weird, so just bear with me. So imagine that you have liquid water, okay? And let's say that you have a block of ice. So if you want to change ice into water, you have to heat it. So heat has to go into the system in order to change solid to liquid. So if you had liquid water and you want to change it back into ice, what has to happen? Heat has to be given off. Not what you might expect, but it's true. So when liquid water changes into ice, heat will be given off. So inside of Pluto, you've got this mantle that is composed of solid water and then liquid water. And so as it's changing from liquid to solid, it generates some heat, and then that heat is what drives the plate tectonics on the surface of Pluto. It also has an atmosphere. So you can see that its atmosphere is composed of nitrogen and methane and carbon monoxide. But look at that pressure. The pressure on Venus is 1/20,000,000th of the pressure on Earth. So what does that say about the thickness of the atmosphere on Pluto? Very, very thin. Okay, because it's a very small object. Doesn't have much gravity, can't hold on to an atmosphere very well. So for all intents and purposes, it doesn't really have an atmosphere just like the moon, but it has a slight atmosphere to it. What about the temperature? Cold. Cold, cold, cold. So if you look at the temperature there, you can see that all year long on the planet Pluto, it never gets above, negative 226 degrees Celsius. It's because it's so very far away from the sun. But remember, it has this very weird orbit, so that sometimes it gets closer to the sun than other times. And so we're going to call this a super summer, and it occurs, every million years or so. And then the temperature on the surface gets up to a blazing negative 223 degrees Celsius, as opposed to its normal negative 236 degrees Celsius. Well, I guess that's hotter, but it's really not that hot, even during one of these super summer things. Okay, so that gives you some interesting things about Pluto. So it's now time to take your quiz over this stuff. So I will see you in just a moment.